molecule. Okay. So when there is a migration of one group from one place to another, either in same molecule or different molecules, it is called rearrangement. So rearrangement can be classified into two types. One is the intramolecular and second is the intermolecular. Already these things have been in the 11 or 12 standard. So what is meant by intermolecular rearrangement? What is meant by intra? What is meant by inter and intra?
Okay, so yesterday we seen that is proton coupled with what? Other important nuclei. So today we will see about we will see the proton coupling with. So you seen the PDF? Hello?
Yes, sir.
Okay. So in this yesterday we seen that is proton coupled with what? Different nuclei. Okay. And what the nuclei are? That is just wait. Okay. So which these nuclei? So nuclei of F19, deuterium, phosphorus 31.
सर नाही दिसत आहे.
दिसत नाहीये?
नाही पीडीएफ नाही दिसत, फक्त ते पीडीएफ दिसते, बुक नाही दिसत तुम्ही शिकवता ते.
Okay.
I think in a way, I will send you a private message. Let's read and do proceed.
Right now? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so yesterday you seen that is the fluorine and deuterium. Okay, so today we will see about the phosphorus. Okay, so in case of phosphorus nuclei, that is coupling of proton to phosphorus 31. So 31 is the mass number, all of you know that. Okay, so when the phosphorus nuclei couple with proteins, then what happen? If you see the abundance, that is natural abundance of phosphorus 31 is about 100%. Okay, and its spin number is 1/2. So therefore there is a no electrical quadrupole moment. Okay, so that two things are important. First one is what? P31, its natural abundance is a 100%, and its spin number is of what? 1/2. And therefore they do not have electrical quadrupole movement. Okay, all of you understand?
Yes, sir.
Okay.
Yes, sir.
So when we say the multiplicity rule for proton phosphorus splitting are the same as those for the proton splitting. So if you see in case of proton, so proton having spin number 1/2, as you know all. Okay, so as like that, phosphorus 31 also having spin number 31, its natural abundance is 100%, and that's why there is a no quadrupole, electrical quadrupole movement, and that's why the multiplicity rule for the proton phosphorus splitting, means coupling with proton and phosphorus, is what are the same as those for the proton splitting. Okay, means you know that HH coupling. So that HH coupling is similar like what? HP coupling. So, but what happened? The coupling constants are large. So G value for hydrogen, that is proton, coupled with phosphorus, it is nearly about 200 to 700 hertz. Okay, and when the proton attached to the carbon, so there is a proton attached to the carbon coupled with phosphorus, then its coupling constant, that is J value, is 0.5 to 20 hertz. Okay, so that is the difference. Okay, all of you understand this one?
Yes, sir.
Okay, but what is important here? You have to always keep in mind that multiplicity rule for proton phosphorus splitting are the same as those of proton proton splitting. Okay, and observable though at least 4 bonds. So if you see the phosphorative nucleus can be observed at appropriate frequency and magnetic field. Okay, so when we want to see the phosphorus nucleus, then what is important? There is a can be observed at appropriate frequency and magnetic field. So this is the short information about the phosphorus coupled with proton. Okay, all of you understand? Yes, no?
Yes, sir.
Okay. Then
Yes, sir.
next see coupling of protons to silicon 29. So this is another nucleus, silicon 29. So in this case, what happened? The NMR active silicon 29 isotope has a natural abundance of only 4.70%. So if you compare the silicon having mass number 29 and silicon having mass number 28, then what happened? The silicon having mass number 28 gives 92.28%. So its natural abundance is more. Okay, while the silicon having 29 atomic mass, then its natural abundance is only 4.70%. And its spin number is what? 1/2. So no doubt it is acts as like proton, because proton having spin quantum number half. Okay, okay, all of you understand?
Yes, sir.
Yes, sir.
Okay, so you see here the value for coupling constant, that is silicon 29 is coupling with CH. Okay, that proton, it is about what? 6 hertz. It is about 6 hertz, and the low intensity doublet caused by silicon CH3 coupling can be often seen standard strading, that is plus minus 3 hertz. Okay, so when your intensity of doublet, it is due to why? Because of the interaction between silicon 29 nucleus with proton which having CH3. So here is what? CH, it is about 6 hertz, but here is what? CH3, and that coupling is often strading. Okay, it coupling strading, and the value of this is plus minus 3 hertz, an amplified peak of TMS. Okay, and the low intensity, that is C13. If this, you know that C12 is having 99% isotope, but here is the C13 is there, then what happen? It is called as a satellite doublet, can also be seen at plus minus 59 hertz. Okay, if this CS3 is C13, generally here is what? C12, then what happen? There is a plus minus 3 hertz. But if there is C13, then what happen? It is called as a satellite doublet, and that can be seen at plus minus 59 hertz. Okay, and silicon 29 spectra can be obtained at the appropriate frequency and magnetic field. Okay, so all of you write this one. The phosphorus 31 nucleus can be observed at appropriate frequency and magnetic field. As like the same, the silicon 29 spectra can be obtained at appropriate frequency and magnetic field. Okay, all of you understand this one?
Yes, sir.
Means what happens? If
Satellite doublet means, sir.
yes,
Satellite doublet means.
okay, I tell you. Here you see C12 carbon atom. C12 means what? It's isotope. Carbon isotope is what? 12, having a mass number. But when it is coupled with C13, okay, here is the nature of carbon is what? C13, and its intensity is what? Low intensity, and that's why doublet can be seen. So it is called as a satellite. When silicon coupled with C13 and that attached to the proton, then it is called as a satellite doublet, and that can be observed at what? Plus minus 59 hertz. Understand?
Yes, sir.
Okay. So that point you mention in your notebook, because these all points we will see during time of solve the NMR problems. Okay. So all of you understand about silicon?
Yes, sir.
And what you keep in mind here, silicon having two isotope, 29 isotope only having 4.70% abundance, while silicon 28 having 92.28 natural abundance. Okay. Yes, is it correct? Now, what is most important part we want to see, that is C13. And you know that after proton NMR spectroscopy, you will study the C13 NMR spectroscopy. Yes? Hello?
Yes, sir.
Yes, sir.
So, if you see, as compared with C12, C13 only having only 1.1% abundance. Natural abundance of C13 is what? 1.1%. And that's why what happened, if you go for the instrumentation, the C13 NMR requires more time because of its natural abundance is very low, and that's why it required more time. Okay. And its spin number is 1/2. So you know that 1/2 is like a proton spin quantum number. So proton directly attached to the C13 are split into doublet with large coupling constant. So along with all other nucleus, what you important here, that is coupling constant with C13 nucleus is large coupling constant, and the value of that large coupling constant is what? It is about 115 to 270 hertz. If you compare that value with previously seen nucleus like deuterium, silicon, phosphorus, the coupling constant value is very high in case of what? C13 nucleus. Why it is high? Because the natural abundance of C13 is very low, that's 1.1 only, and that's why it required more time for the abundance in the instrumentation, and that's why its coupling constant value is also more large. If you see for C13H, the CH3CH2 group, for example, is predominantly, suppose this nucleus of methyl group is C12, this also having C12, but contains a small amount of C13 and C12, or C12 C13. So there may be in this compound their possibility is what? There is a small amount of C13, here is the small amount of C13. Thus the CH3 protons are split into doublet by what? C13, the J coupling constant value is near about 120 hertz, and each peak of doublet is split into triplet by the C12 CH2 protons, and its value is 7 hertz. So if you see the proton coupled with C13, then its J value is what? 120 hertz, and when it having C12, then what? Its value 7 hertz. So that is the big difference. And why this is big difference? So because of abundance of C13 is very low. It is about 1.1% only. Okay. And these C13 satellite peak are small because of small number of molecule containing CH3 group and can usually be seen deposited on both sides of large, that is C12 CH3 peak. Okay, so means what? Here, this compound is here, CH3 CH2. In that compound, there is C13 as well as C13 CH2, C13 CH3 groups are there. Okay, so you mention here, that is CH3, here is the C13, here is the C13. Okay, and its natural abundance is very, very low. And that's why coupling constant value is more. While in case of C12, the coupling constant value is near about 7 Hertz. All of you understand this one?
Yes,
Hello? Hello?
Hello.
All of you
Yes, sir.
understand? Okay.
सर कार्बन 12 कपलिंग कसं करेल हायड्रोजन सोबत
Yes?
कार्बन 12 कपलिंग कसं करेल हायड्रोजन सोबत जे व्हॅल्यू नियरली 7 हर्ट्ज कशामुळे येते
This one, no?
हा
Because of C12 nucleus coupled with the hydrogen.
बट सर स्वीट इज इनएक्टिव्ह ना
Yes, C12 is inactive, but what happened in this compound? Okay, there is a coupling occur with every nucleus in the molecule. Okay,
ओके
and due to this inactive of C12, the less value is there, that is 7 Hertz, because the H couple with something, that is C12, but C12 is what? NMR inactive. Okay,
यस
and that's why its value is what? Near about 7 Hertz. But in case of C13, what happened? You observe the large coupling constant value. Okay,
ठीक आहे
yes, you understand?
मी सर
Yes.
13 सी मुळे हे आपलं 12 CH2 चं प्रोटॉन कपल व्हायला ओके
Yes. If you see here, CH3 C13 is there, then what happened? There is a J coupling constant value. Here is what? C12. So it is near about 7 Hertz. But here C13 C12, it is also near about 7 Hertz. Okay, but there is a direct coupling of this CH3 C13 with hydrogen, then its value is what? 120 Hertz. Okay, understand through this diagram?
ओके
Okay, so these are the nucleus. Which one? How many? Fluorine 19, deuterium, phosphorus 31, silicon 29, and C13.
Silicon.
Among these, C13 gives higher coupling constant value. Okay, so all of you understand this coupling of proton is important nuclei.
Yes, sir.
Yes or no?
Yes, sir.
Okay.
Yes,
So,
sir.
I think in case of NMR, we see the maximum part. Okay, and right now, along with the examples, we will see some important points related to NMR spectroscopy. That is simple spectra, double spectrum, okay, complex spectrum. So from next lecture, we will see that. And before that, you always try to concentrate to see the terminology which is used in what? NMR spectroscopy. So today, I think, today or tomorrow, I will provide to you link and you submit whatever assignment given by you during last, I think, 2 or 3 weeks before. So everyone should submit your assignment on that email. So I will send that message on your WhatsApp group and then you will send it. Okay? And hope so.
Okay, sir.
Everyone write that notes along with the examples. I mostly like, suppose shielding, de-shielding pattern is there, then you explain that pattern with what? Different examples. Okay, I expect that. So everyone understand? Yes, no?
Yes, sir.
Okay, I
Yes,
think
sir.
your COC class will start because 11:04 is there. So you leave the class and join there. Okay? Have a nice day. Stay at home. Thank you. So everyone leave the class. सर काकडे कोकाडे सर कंपार्टमेंट करून घ्यायला पाहिजे जरा. लय डिस्टर्ब होतं ना.
कधी बसलो होतो?
हा
टी-शर्ट घालून जा.
सुरू झालं.
गाडीचे पोरं त्याला वेगळं होते.
नाही ऑटो जॉईन करून घ्या की सर.
आठवड्यांचे ते मध्ये आवाज तीन येत राहते की.
हा मग ठीक आहे ते क्लिक करण्यापेक्षा ते चांगलं आहे की.
ते चांगलं आहे. पण मध्ये ते सात आवाज ते येत राहते.
हा हा रेकॉर्डिंग सुरू आहे बहुतेक. स्टॉप म्हणायचं.